But in eager functional languages like Lisp, like F#, you cannot create infinite lists. Whenever you create a list, it puts things into memory, so you cannot create something which is like not of a finite length. How can you still deal with those kind of structures in F#? Let's we would have now to use one of the non-pure functional concepts in F#, which is called mutable variables. So you may know that you can define a variable x as mutable. Let's say let mutable x equals to 10. And then this mutable variable supports assignment operator. You can say x assign 15, and then the value of x will be 15. So this is, of course, non-purely functional, but I would need this to emulate generators in F#. So once we know what is a mutable variable, I can define function generator gen x. Let me call it not generator, but for example counter. It would be a counter. Let counter x. Let me actually leave this code because you may want to have a look at it later on. So I will leave this cell, and then I would say let counter x equals 2. So what I will do here, I would say let mutable c equals to x, and then I would return a function which whenever you call this function, it would increase the value of c. So it would say c equals c plus 1, and then it would return the current value of c. So if I say let g equals counter 0, what will happen? If I call g for the first time, it would give me the value of 1. If I call it the second time, it will give me the value of 2, 3, 4, and so on. I can call this function g infinitely, and it will give me the new values of the variable, right? So this is called generator. It is not purely functional, but the good thing about generators is that you can define on top of them, you can define all the standard list operations like map, filter, and so on. So let's try to put the mutable ugliness into one place so that we never need to come back to it, but we just have the concept of generators. By the way, this concept of generators, does it remind you of some concept you learn when you learn C#? Like, what is the analog of generators in C#? In C# you have arrays, right? And you can operate on arrays. You can do like for each loop on the array. But there is also something else on which you can do for each loop, which is what? Anyone? So you in .NET you have IEnumerable interface, right? IEnumerable interface gives you, in fact, a generator. It gives you a function which returns on each call. It returns the next element of a sequence. It also has another function which checks if the sequence has ended or not. Our generators they kind of define infinite sequences, but the IEnumerable interface is the very close analog of generators. So now what we can do here, we can define like a very generic way to construct generators. I will call it unfold. So here, when I define this counter, I basically had this state, the value of the state C, and then on each call I change the state and return the next value. So if I want to do it in a generic way, what I can do, I can pass the function f here and the initial value I. So in the beginning, the state would be equal to I. Then state would be computed as f of s, and I would return the current value of state. So that would be the generic way to construct generator. And if I want to define a counter, I would say unfold. The state function will be +1, and the initial state will be 0. This would give me the counter 1, 2, 3, 4. So then if I want to define Fibonacci numbers, how I would do that? Why, by the way, it's called unfold? Because it has kind of opposite effect to fold. Fold goes with the state through all elements of a list, and unfold starts with the state and then kind of applies the transformation at each step and returns the next value. So if I want to define the Fibonacci, how would I do that? With unfold. What would be the state? Anyone still with me?
I think we need two variables.
Right. Yeah, we need two variables for the state. So it would be like u and v. And the function which does the state transformation would do the following. From uv, it will go to u plus v u, right? It would shift one step. And I will start with 1, 1. So that would give me, at the first step, it will give me what's wrong here? I forgot to unfold. 1, 3, 2, 5, 3, and so on. So it would give me this kind of sequence of pairs for Fibonacci sequence. But if I don't want the sequence of pairs, if I want just Fibonacci numbers, what do I do? I need to, if it was a list, right, I would just do map. I would do map FST, and it would give me the value of first elements for each pair. Here, what I can do, I can define the map on top of generators. How would I do that? I would say let map f and then generator g equals to. So the map should return a function again, right? So it would return a new generator. And this generator, what it will do, it would call the generator g and then apply the function f on the result, right? So it would be f of equal to g. Then I can say let fibs equals to map fst again. If I start calling that, it would give me 21, 34, 55, and so on. It started like it started not from the beginning because I have already retrieved a few values from FibGen generator. If I want to start from the beginning, I need to redefine it, and then I need to redefine this as well because it captures it's a closure. It captures the current value of FibGen. Once I do that, it starts generating Fibonacci numbers. Not from the first one, though. If I want the first one, I need to map SND, the second value of the pair. From here. Okay, what else I can define on top of sequences? I can define filter, right? How I would define filter? I would say filter, predicate P, and generator G. But filter only needs to return values which satisfy the predicate P. So how can I do that? I need to compute the next value of G, right? Because I need to refer to it a few times. So I would say let X equals G. It would retrieve the next element. And then if P of X, if it satisfies the predicate, then I will return X. And otherwise, what I need to return? I need to start with the next element, right? So I would need to return filter P of G. Of G without brackets. But filter P of G gives me the generator, but I need to return the value here, so like this. Yes. And now I can solve the, for example, the Euler problem. There is a Euler problem number 2, I think. You know, the project Euler, the simplest, like some simple problems to learn programming. And the number 2 says, find the sum of even valued terms of Fibonacci numbers which do not exceed 4 million. So if I want to solve something like this, generators is the perfect way to solve this, because I cannot create the list of Fibonacci numbers up to 4 million, because that would be too large. But if I have the generator, I can easily program something like this in the way I would normally do with lists. I would say, here is the list of the infinite sequence of Fibonacci numbers. Then I somehow end it whenever it becomes more than 4 million, and then I do the fold on top of them. So with the generators, you can do that. But if you just want to find the Fibonacci number which exceeds 4 million, how would you do that? You would say fibs, then you would say filter. You need to only even numbers which exceeds 4 million. So I would say fun x, or I would say here divisible by 2. I have already defined, I think, this function. And then I would say filter x greater than 4 million. And I would define this as a sequence, and then I would get the first element. This, of course, I meant. So here is the Fibonacci, the first Fibonacci number which exceeds 4 million. And you can see that in terms of the code becomes very clear, like it's the same as you would do with lists. But in terms of execution, it is the same loop as you would define with while loop if you were programming like in C or C# or whatever. Because in C#, if you want to find this even Fibonacci number which is greater than 4 million, you would do the while loop. Inside the loop, you would do the state transformation on 2 variables, and that's it. But when you do the loop, you cannot deconstruct the logic of the loop, right? Because the logic of the loop is all inside the loop. And if you have some complex logic there, you would need to do the big, huge loop with all the code inside. And that would not be convenient, because you cannot deal with complexity, correct? So here, when you start doing sequences, you can deconstruct the logic. You define the logic of the loop, the generator logic of the loop in the beginning. Then you can do filters, maps, and then you retrieve the results. So it kind of puts the loop, how to sort of say it, upside down. Like it's the code is structured in the opposite way, and which makes it easy to decompose. So this notion of filters, it is built inside of F#, and it is called sequences. So sequence is the same, is very similar to list in the sense that it supports all the same operations, but it is defined using IEnumerables. So behind the scene, the sequence is equivalent to .NET IEnumerable. So whenever you, for example, if you do interoperation between C# and F#, any IEnumerable is regarded as a sequence in F#. So in terms of sequences, you would define Fibonacci like this. You would say fibs equals to sequence unfold. And sequence unfold is a little bit more tricky than the one we have seen. It takes in like this the initial state and the function, which takes the current state, and it returns two things. It returns the next state, and it returns the part of the state which you need to return. So this sequence unfold allows me to define Fibonacci sequence immediately without the map. So I would say here I want to return v, and the new state, which would be u plus v u. And I return the option. I put sum here. Sum means option type. I use option type here because the sequence also supports termination. Sequence can add at some point. It can be finite. And for finite sequences, you need to somehow let generator know when the fixed sequence has ended. So here you can put like none if you want the sequence to end. That would be the sequence of Fibonacci numbers. And if you print it, I forgot, I cannot do like this in the Jupyter Notebook, because the Jupyter Notebook always tries to compute all elements of the sequence. So now I would need to restart the kernel. So if I want to take only a few elements of the sequence, I would say sequence take 10. And this would give me first 10 values of Fibonacci sequence. Here it is. So yeah, and then with the sequences, I can use all the standards like sequence .map. And then, for example, I want to multiply each element by 2, and then I can do sequence.filter divisible by 2, and then I can do sequence. I think you can also do sequence take while. And then sequence.fold. Let me actually get rid of the map and do the Euler problem. So it says even numbers which are less than 4 million, and you need to compute the sum of them. So I would say then sequence.fold plus 0. Divisible by I need to define because I did the reset of the kernel. So that gives me the solution. I think 4 million is 1 0 more. So this is the solution for Euler problem number 2. Okay, so that is sequences. Now, one more thing about defining sequences is that you can define them using the Yeah, and one more thing, that with sequences you can do things like you can define infinite sequences. You can say sequence from 1 to 100, and that would give you this kind of generator which generates all numbers from 1 to 100. And or you can do like you can say sequence.
Всем привет.
Hello, we can hear you, by the way. Okay, so let's now see one more way the sequences can be defined using the special syntax called like special sequence syntax. You can do the following. You can say let s equals to sequence, and in sequence you can write. This is similar to generators in Python. You can write any function. You can say, like, for example, for x. I forgot the syntax for in. Yeah, let me first also show you that you can do like sequence for x in 1 to 10 to yield x to x. Yeah, so you can define sequences in this way. You can use like any code and the yield operator. Yield means you need to return the next element as the element of the sequence. So here I have this kind of for loop and yield, and whenever I have yield, it gives me like the next element of the sequence. But this can also be done. So if I want to define like Fibonacci numbers in this sequence, I would say let fibs equals to sequence. Then I would say let s equals 1 1. Let me actually do let u v equals 1 1, and then I would do while true. Do I have while true here? I'm forgetting the syntax, by the way. Let me go for the syntax. While true, I would say it is an ugly way to define it. So u equals. How can I define this without temporary variable? If I cannot do assignment to the tuple, so I have to say u equal assign something to u and assign something to v. So how do I do the assignment without temporary variable? I do with temporary variable. S equals u plus v, then v equals to u equals to s yield v. So that would give me the, oh shit, sorry. It should give defined in the same manner. But this is definitely very ugly. So normally you don't want to write anything like this in the functional programming language because it's explicitly non-functional. It has mutable variables and while and so on. So the reason I do that is to demonstrate the syntax and the idea of yield, and that you can do things in a different way. But the proper way to do that is to use the idea of co-recursion. And I will show you in a second what I mean by that. This is the sequence of Fibonacci again. So co-recursion is essentially using the recursion in sequence definition. Let me first define not Fibonacci sequences, but just the numbers 1, 2, 3, 4, 5. Let me actually define something very simple, like that's the infinite sequence of ones. How can I do the infinite sequence of ones? Of course, I can do while true do yield 1. This would give me a sequence of ones, but that's not the good way to do it. Again, not very functional because I use this while, and I don't need rec, by the way, here because it's not recursive. But if I want to define it in another way, I would do the following. I would say I would think like this. So what do I need to do to generate the sequence, the infinite sequence of ones? The first element would be 1, so I would say yield 1. And then I need to return the whole sequence again, right? So I would say yield exclamation mark ones. And that would give me the infinite sequence of ones. So you see, I used here the whole sequence again as the kind of recursive call. And instead of yield, I use yield exclamation mark. Yield exclamation mark takes another sequence and returns it at this place. So you see, it kind of similar to recursive call because it uses the same name, but it is not like recursion because recursion has this if which terminates the recursion, right? You have to define somehow where recursion would end. But in this co-recursion, so I would put here co-recursion. In the co-recursion, you don't need to do that because you end the co-recursion by specifying how many elements of the sequence you need to take. Right? Now, a little bit more tricky thing. How you would do co-recursion if you want to do 1, 2, 3, 4, 5. That's a little bit more difficult. So, like, let's say nums. So how would I do that? Again, I return 1 as the number, and then what do I need to return next? I cannot just return the sequence of nums. I need to increase this sequence of nums by 1, right? So if I first return 1, then I need to do 1, 2, 3, 4, 5, but plus 1. So here, what I can do, I can say yield sequence map plus 1 nums. And this will return sequence 1, 2, 3, 4, 5. So how would you do this with Fibonacci if you want to define Fibonacci in this manner? Any thoughts?
Like in first realizing of Fibonacci, we use pair of U and V, and in the next iteration we give U plus V and V as new pair.
Exactly, yeah. So here I would return pairs. The first one would be 1, 1, and then the next pair would be from UV, I would map to U plus V U and to fibs. Then I would need to do a sequence map SMB again. So that would be the sequence of Fibonacci numbers. Good. So this is called co-recursion. Because why it's called co-recursion? Because it's kind of opposite to recursion. Opposite in the way that recursion checks the condition first and then does the call if necessary. And this one does not. This one always kind of defines infinite sequence, and then using sequence take, you define how many elements you actually want. And this kind of sequences and generators, they are sometimes called codata, because it's not like data. Data is when something is stored in memory, and codata is when you have the function which generates this data. So co-recursion and codata. How can you use this in practice? In practice, it gives you a good opportunity to use list-like operations on large data, which does not necessarily needs to fit into memory. So you can, for example, define the generator which reads the file line by line, and the file can be large, it can stay on disk, and the generator would still allow you to create the sequence which you then would be able to process step by step using normal sequence operations. So let's see an example. How do you define this generator? Let me try to do that. So let read fn equals to sequence. How do you open the file so that you can read it line by line? I cannot possibly remember that. This is a nice page, by the way, for you to look at. Okay, actually, let me stream reader. Something like this, I think, should work. But of course, I do something. Is a property, probably, right? Good, I figured this out. So this is, I have the book War and Peace there on disk, And now I did a stupid mistake again, and I read it all into one sequence and plot it on the screen. So I should never do that. I should always say sequence take. So this is the War and Peace by Leo Tolstoy, which is supposed to be a big book in English for simplicity. And I can process it line by line. I don't have to read it all on disk. Now let's do some interesting things with some, like suppose you want to, for example, find the longest word in this book. How you would do that? If you were doing it using for loop, that would be quite like using the while loop. It would be quite difficult thing because you would read it line by line. Then each line you need to split by word, and then for each word you need to compute the maximum. So that would be quite a complex algorithm. So here, what you can do, you can say, okay, I want to do the mapping. I want to map it, and for each line, I would do s.split, and I split it using like space dot comma whatever like character I need. So this would return me like lines, and each line would be in turn an array. So to flatten this, to make it a flattened array, you can use sequence concat, I think it's called. So this would concatenate all subsequences into one, and it would give me just one sequence of words. And of course, I want to do them probably lowercase. Sequence.map fun s to lower. And then I need to filter out. I want to get rid of the empty sequences because when I have two spaces two spaces together, that would give me an empty sequence. So I would say filter of s.length greater than 0. So this is the sequence of words. And if I want to find the word with the like the longest word, what is the longest word? I would say fun s dot length, and then sequence dot max, and this would give me 27, the longest word. No, the length of the longest word. And if I want the longest word itself, I would do sequence max by and specify this length. So this is the longest word, which is not quite fair, right? Because it doesn't seem like one word. So I need to put the separator here as well. It's a Unicode long dash. Trademark copyright is also not the good word. So I would need to put the brackets for separators as well. So this is now the longest word characteristically. What else can I do? I can do some funny experimentation here. Like I can see like characteristically is a long word, but what is the number of words of different length, right? I can also do that. How would I do that? I would use let me just do the frequency dictionary first. So frequency dictionary, I want to say how many times each word appears in the file. So now I have the list of words, and I can use, so here is the list of words again. That's how it looks. And then I need to also to keep this. So now what I can do to compute the frequency dictionary, I can use clever thing. I can use sequence group by. And sequence group by does the following. It applies some function on top of words. Like I would use the identity function to begin with. And so, for example, it takes the first word there, and then it groups all elements of the sequence which has the same value of function. So it groups all occurrences of there together. So it will do and then project, and it will group all occurrences. So you see what it does. It does grouping by the value of this function. So if I want to group, for example, by the length of the word, I would do like this: group by s length, and it would give me all words of length 3, all words of length 7, all words of length 9, and so on, grouped into one place as another sequence. So if I want to do frequency dictionary, I would just do this, and then I would need to calculate how many times each word appears. Here, fun s, like ws, and I would return the word and the sequence.length of s. So it would give me now the frequency dictionary. This is the frequency dictionary. And if I want to find the most frequent words, I would do sequence.sort by, and I would sort by -s. And this would be the most frequent words. And I can in fact do that in the nice form. I can say chart.bar, and it would give me this kind of graph of words and their frequencies. How would I, by the way, use this sort by in the more, like in the nicer form? If I want to write it in the functional way, what I do here, I take the second argument and I apply the unary minus. So I can say here snd followed by unary minus. This would be the same. It's not working. Strange. Is the trick, but I don't understand why unary minus doesn't work. Maybe it's like this. No. Okay, now I probably forgot something about unary minus sharp. Let's leave it like this. So that's kind of a way you can easily operate with sequences. So I think that's it for theoretical material for today. I would also suggest you to study in the lectures. You have the next section, which I think number 5, which talks about closures, sequences, and it also talks about some more material which I did not cover, like it talks about memorization, and so I suggest you to go through those lectures as well. And then for this time and for next week, you would have the lab to work on, the next lab, which is kind of not very easy, but I will talk about it in a moment. Let me try to find them. The lab, so this is the lab number 3, and the idea is the following. Like, suppose you want to define in F# a kind of way to represent formatted documents. Normally, like if you want in the real life, if you want to format a document nicely, you would use something like Markdown, or you can use HTML, or you can use, whenever you use Word, essentially you can use TeX. So whenever you, whichever way you take the formatted text, what you do, you have the text and you have some additional like Markdown, which specifies how this should be shown on screen. So the lab number 3 deals with this kind of formatted document. Your goal would be to represent this formatted document in F#, and then like do something with it, either print it in some way or take the document from the disk as text and represent it as formatted document. So how can you do that in F#? In F# you have the rich typing system, right? So you can say type doc equals to. So now you can say what is formatted document. You can say that formatted document can be a paragraph of string. Paragraph or rather you can say that formatted document is S of string. So whenever you want to represent a string, you would say S. It can be a paragraph of doc. It can be, for example, if you want to represent bold, you can say bold of doc. And then you need also like some other things like formatted list and so on. But this, if you want just to represent the bold or italic, you can do something like this. And then you would be able to say let x equals bold of, you can say paragraph of bold of it says it should be uppercase. That would be the simplest formatted document. So in the lab, what you need to do, you need to design the data type to represent this formatted document using paragraphs, validated item lists, bold italic text, and headers. It's like very simple subset of HTML. Then you need to write a function which takes this document and renders it using one of the formats, and the format is defined by your number in the list. So it can be either Markdown or HTML, or it can be like PostScript-like stack language. So the idea of, if you know that what a PostScript is the language for printers. It was designed for printers so that you can send the documents in the rich format and it would print them accordingly. And the idea of PostScript is that it is stack-based language. So you have the operation to put the string on stack. Then you have the operation to switch to bold, italic, or normal. And you have the operation to print the line. And then you have the operations to switch between headers to next and previous level. So the idea is that if you want to print the bold string, you would put the string on disk, you would switch to bold, and then you would call the P command. If you want to print like bold and italic, you would say this string and then bold and then italic and then print. And then if you want to print something in bold and then normal, then you would put first string which you want to print in bold, switch to bold, print, then put the normal string, switch to normal, and print. So this kind of sequence of commands you need to generate for your document. And then the third exercise is the most complex one. You need to take as input either HTML, XHTML document, which means very well formatted HTML, or the second option would be simplified version of Markdown, meaning Markdown without like all the complex syntax, but just supporting the commands that you need. And you need to parse this text document into your defined data type. So you would have those two functions, from text to internal representation, from internal representation to one of those. So and by building those two functions, you would in fact build the converter, like for example from Markdown to HTML or from XHTML to PostScript. So depending on your number, you would build different converters. And then you would also need to write a function which strips all the formatting and produces plain text, which would be a simple tree traversal exercise. And finally, the number 5, the final task is unrelated to the first one. It's just you have the large text and you need to calculate something from it. It is similar to the exercise that I have just shown you with War and Peace. You just need to show some kind of interesting value from big text, and the text you can take from here. It has the links here. One more interesting thing here is that you can download text from the internet directly without putting it on disk. So this is the next lab. It's pretty big, especially if you need to define parsing. Parsing would take a little bit of thinking of how to do that in the best possible way. And so you have this week and the next one to work on this lab. So next week, I suggest that we do not meet. You just work on the lab, and if you have any questions, you let me know. Okay, any questions you have for me?
Can you share the notebook which you used this lesson?
Yes, that is a great question, and I will do that.
Thank you.
I will share in the in Teams. Once we finish the call, I will share in Teams. Okay, so any further questions, if you have them, please use Telegram. Oh, somebody suggested how to use unary minus. Thanks a lot. Let me try that actually. So unary minus. Excellent, that works. Thanks for your help. Okay, so if no further questions, ask questions in Telegram, and we don't meet next week. You work on lab, and then the one after next, we will decide what to do. Okay, have a great day.
Thank you. Goodbye.
Bye.